Hello everyone, my name is Tadele Kasahun and I am pleased to welcome you to this blended course on time series analysis. I have been teaching and working in the field of statistics for over 7 years experience, and I currently serve as a lecturer in the Department of Statistics at Dewark University. I hold a master's degree in statistics with a specialization in econometrics, which gives me thus both practical and theoretical experience in analyzing data over time, modeling trends, and interpreting the patterns. This course will focus on time series analysis, where we explore how data evolves over time, uncover patterns, and make forecasts. Throughout this course, we will combine theory, practical examples, and hands-on exercises. So you can see how the concepts are applied in real-world contexts. Before we begin, I want to acknowledge that all course materials are copyright protected and they are intended for your educational use within this class only. I'm excited to guide you through this course, and I encourage you to ask questions, participate actively, and apply the methods we learn to practical datasets. Now, let us move to chapter 1, where we'll start by understanding the fundamentals of time series data. That we have introduced the course, let us look at the learning objective for this chapter. These are what we aim for you to achieve by the end of this session. The first one, define learning time series data and the core objectives of temporal statistical analysis. The goal of temporal analysis is to detect patterns, trends, and change over time and use them to forecast future behavior. The second one, identify time series concepts, trend, seasonal, cyclical, and irregular variations. And the third one, distinguish between additive and multiplicative models for various data structures. Keeping these objectives in mind will guide us as we explore time series data, its components, and how to model it effectively. Now, let us define time series. A time series is a sequence of observations that are arranged according to the time of their outcome. The key idea here, the order of the data matters. That means we record it in the order it happens, not randomly. Many sets of data appear as time series analysis. For example, yearly sequence of the quantity of goods shipped from a factory. We can see trend over several years, such as increasing or decreasing production. The other one is it may be thus monthly series of number of road accidents. Here we might notice seasonal peaks like more accidents in rainy months. Weekly business section reports of stock prices. The data allows investors to see trends and volatility over time. And it may be that the data daily maximum and minimum temperatures and annual rainfall. These show patterns and fluctuation which help in the forecasting and planning. You can think of a time series like movie of data unfolding over time. Each observation is like a frame. Only when we look at the data in order to we see the pattern, trend, or seasonality. Generally, the characteristics of time series data, it may be that time series data are sequential, not independent. This means each observation is often influenced by previous values. For example, today's stock price may depend on yesterday's price. Their variability may change over time. Some periods may be calm with small fluctuation, while others may be more volatile. Think of it like a clock. Each tick represents a data point. Only by recording data at regular intervals and in order can we accurately observe patterns, make forecasts, and perform analysis. Let us look at that's the main types of the data that's commonly used in the quantitative analysis. The first one is time series data. These observations recorded over time at regular intervals. That means the nature of the data is as time series data. For example, daily stock price, monthly sales, or yearly rainfall. Here, the focus in on the patterns over time, such as trend, seasonality, and cycles. The second one, cross-sectional data, observation collected at a single point in time across different subjects. For instance, a survey of household incomes in a city this year or students' test score in one semester. The focus here on the difference between subjects, not changes over time. That we call it cross-sectional data. The panel data, a combination of time series and cross-sectional data. It tracks multiple subjects over time. For example, mentoring the monthly sales of several stores over a year or following the performance of multiple students across several semesters. Panel data allows us to study both changes over time and differences across subjects. Simply to visualize it, time series one line over time and the cross-sectional data many points in a snapshot. Panel data thus many lines each representing a subject moving over time. Understanding the type of data you have is a crucial because it determines which analysis techniques are appropriate. Now let us talk about the time series plot. That's also called as a time plot. A time plot is simply a graph of observations against time. It is a way to visualize the data as it unfolds over time. The main purpose is to highlight important features in the series, such as it may be the trend, seasonality, outliers, change in structure. That means, in general, a time plot is a visual representation of how a variable changes over a specific interval of time. That helping us detect patterns and irregularities that are not obvious from raw numbers. Imagine plotting of the daily temperature over a month. The line may rise during daytime and fall at night, showing a trend and seasonality, and maybe a sudden storm creates an outlier. Remember, a time series plot is the first step in analysis. It gives you an immediate sense of the data before we start modeling or calculating statistics. Let us look at this example of a time series plot. The US wholesale price index from 1960 to 1990. This plot shows the first difference of the log transformed WPI, which is a common technique in the time series analysis to stabilize the variance and remove the trend. Notice how the values fluctuate around the mean. Notice how the values fluctuates around zero, which some peaks with some peaks and dips. This represents the changes in the wholesale price from one period to the next rather than the raw levels. We can observe periods with more volatility, like around the mid of the 19 1970 and early 1980 and early 1980s likely related to economic events or inflationary pressures. This type of plot helps analyze identify whether the series is stationary. It's like statistical properties like mean and variance are constant over time. After differencing, which is important for many modeling methods. In practical terms, by transforming and differencing the data, we remove trend and focus on the short-term movements, which can be easier to model and forecast. This example shows how visualizing time series data in different forms helps us understand its behavior and choose the right analytical tools. Now let us discuss the objective of time series analysis. One key challenge in time series data that observations are not independent, unlike other data types. Here, the value at one time point is often related to previous values. This makes the sequence of data just as important as the actual values themselves. You can think of each data point as bivariate, a pair of t and dyt. That means where t represents time and yt is the value at that time. Time is a fundamental variable that must always be considered. The main objective of time series analysis are description, explanation, prediction, and control. In essence, time series analysis helps us not only understand what has happened, but also does explain why, predict what will happen next time, and make informed a decision. When you focus on the first objective of time series analysis, that's description, the goal here is to summarize and understand the data using both summary statistics like mean, variance, and visual tools, especially the time plot we discussed earlier. By examining these summaries and graphs, we can identify key properties of the series, such as a long-term upward or downward trend and seasonal patterns. To illustrate, think back to the US wholesale price index plot we saw earlier. During the description phase, we notice a steady climb in the long levels, indicating inflation or price increase over time. We also observe high volatility peaks in the mid of 1970s, likely linked to the economic shock such as the oil crisis. Description helps us get a clear picture of what the data looks like before moving on the explain or prediction. We move to the explanation stage of time series analysis, while description tells us what is happening. Then explanation seeks to uncover the why behind the observed patterns. Remember, each data point is a bivariate pair, time and value. So we can look for other variables that changes over the same timeline and might help explain what we see. For example, the sharp rise in the wholesale price during 1970s can be explained by external events like energy crisis during that period. By comparing multiple time series such as energy price and wholesale price, we can understand how one affects the other. Essentially, explanation connects the dots by linking patterns in the data to real world events or other influencing factors. Here, we focus on the next key objective of time series analysis, which is prediction, that's also known as forecasting. At this stage, our goal is to use historical data to estimate what is likely to happen in the future. An important concept to understand here. That means dependency. In time series analysis, data observations are not independent. Each value is influenced by previous values. In other words, the series has a kind of memory. Because of this, we can look at the past patterns such as trends or recurring movements and use them to project where the series is heading next. For example, if inflation has been steadily increasing over recent months, we can use the patterns to forecast inflation for the next quarter. This makes prediction essentially valuable as it provides actionable insights for planning and decision making. So, in this objective, we move from understanding the data to using it to make informed estimate about the future. Next, we come to the final key objective of time series analysis, which is control. At this stage, we are not just describing or predicting the data. We aim to influence or manage the series to achieve desired outcomes. This is where intervention comes into play. If the series is generated by a system that can be adjusted, we can use models to determine the best way to keep the variable within a target range. For example, consider the wholesale price index. A central bank monitor this data and adjusts monetary policy to stabilize prices, preventing extreme inflation or deflation. In other words, control uses the insights from our analysis to actively guide the system, ensuring that it behaves in a desired way rather than just observing or predicting. This objective completes the full cycle of time series analysis from description to explanation to prediction and finally to actionable control. This objective completes the full cycle of time series analysis from description to explanation to prediction and finally to actionable control. Now let us look at the application area of time series analysis. Time series data provide valuable information about a wide range of systems, whether they are physical, biological, social, or economic. In particular, many time series are routinely recorded in economics and finance. This dataset helps us understand trends, cycles, and patterns over time and allow decision maker to plan and respond effectively. For example, tracking stock price, inflation rates, or employment figures over time gives economists and policymakers the tools to analyze the past and forecast future developments. In sense, wherever events or measurements are recorded sequentially over time, time series analysis becomes a critical tool for understanding and action. Let us discuss the significance of time series analysis. The main strength of time series analysis is that it treats data as a sequence, where the order of observation is crucial. This follows us to make sense of the past, present, and the future. First, it helps us understand past behavior in the data. That means identifying trends, patterns, and unusual events. Second, it allows us to see what changes have occurred over time, such as shifts in economic indicators, seasonal effects, or market fluctuations. Third, it plays a key role in planning future operations because insights from past patterns helps forecast like outcomes. It also helps evaluating current accomplishments, telling organizations measure process against historical performance. Finally, the time series analysis facilitates comparisons across periods or between related data sets, that's providing a clear picture of dynamic over time. That's a picture of dynamics over time. Overall, it transforms raw sequential data into actionable knowledge that support informed decision making. In the summary of the section, that concludes this part of the chapter 1. We have covered the definition of time series, its significance, objectives, and we will continue with the next section of this chapter in the following session. Thank you and see you in the next part of chapter 1. Thank you.